Hello guys, today I'm going to be talking about the alkane, alkene, and alkyne functional groups. So just as an introduction to this functional group, these are considered to be aliphatic hydrocarbons. So what that means is that hydrocarbons means that they only have hydrogen and carbon, while aliphatic means that they are not aromatic, which I will be talking about in another video. So, what are the differences between alkane, alkene, and alkyne? So, alkanes are hydrocarbons that only have single bonds or sigma bonds between carbons. So, an example of that can be propane, which has a skeletal structure that looks like this, and a full structure that looks like this. Notice that each of the carbons are bonded to four things, have four bonds, which is what carbon usually does in organic chemistry. Now, alkenes have single bonds, but they also have double bonds between carbons as well. So an example would be ethene, which has a skeleton like that and a full structure like this. Now, alkynes, similarly to alkenes, they have single bonds too, but they also have triple bonds. And an example can be propyne, which looks like this and like this. Now, going into the properties, the chemical properties of this functional group, they are usually highly combustible, meaning that they catch fire easily because they are hydrocarbons, and the formula for hydrocarbons is so you have a hydrocarbon plus oxygen will give you combustion with some water and carbon dioxide. And another important property of the alkane, alkene, and alkynes is that they are non-polar, which gives them a low boiling point and melting point because of low intermolecular forces. And additionally, they can act as a nonpolar solvent if they are a liquid. So, for example, cyclohexane is as so. That's the skeletal formula. And it can dissolve other nonpolar fluids such as oils and oils. So, however, water would not mix well with this because it is nonpolar, meaning that it does not attract well with hydrogen and with water, which is a polar substance. So it's a nonpolar solvent. And just as an example, that might be useful, butane versus butene. Now, butane has a boiling point of about negative 0.5 degrees Celsius, and butene looks like this, which looks pretty similar, but it has a slightly lower boiling point of around -6 degrees Celsius. And this is because butene actually weighs a little less than butane, because this double bond is preventing it from having 2 extra hydrogens, which, because it's an unsaturated hydrocarbon. And since butane is lower in mass, it will have less van der Waals forces, which makes it have a lower boiling point. Now, going into the naming of alkanes, alkenes, and alkynes, what you first want to name is the main chain. So let's take something like this, for example. The main chain is basically the longest possible chain of hydrocarbons. So that would be 1, 2, 3, 4. Wait, so hold on. That would be this chain, because it's longer than just going here. It has more carbons in the chain. And counting the number of carbons, we have 1, 2, 3, 4, 5, 6, and 7 carbons in the chain. So that means we will use heptyl, because that's the main chain. We use heptane as our main chain. But we also have a substituent here, which is basically just something that sticks out of the main chain but isn't actually part of it. And that one has 1 carbon atom, so it is a methyl group. And also, this methyl group is on carbon number 3, so we would call it 3-methylheptane. And let's say there was a double bond right here, or let's put it right here. And so this would change the ending from ane to ene. And if we count the number of the bonds, it is on bond number 4, so it would be hept 4-ene. And similarly, if this was a triple bond instead of a double bond, you would change the ending to ine, so YNE instead of ane or ene. Yeah. So some common reactions that occur with hydrocarbons, with aliphatic hydrocarbons, are free radical reactions, which happen between alkanes and halogens under UV light. So an example would be something like this, with UV light and let's say chlorine. That would give a product something like that. I will not be going into the mechanism in this video. That's going to be another video. So these are for alkanes. Now, something with alkenes and alkynes are addition reactions, which looks something like this. And this reaction also adds halogens. So you had Let's do bromine this time. They add the halogen where the double bond was. So the bromine atoms, the bromine substituents would be added here, and it would get rid of the double bond. And another one would look like this. And notice how it adds 2 pairs of bromine atoms this time when it's an alkyne. I won't be getting into too much of the specifics in this video. That's going to be another video as well. So now for some nomenclature practice. You can pause the video and do these right now if you want. Okay, so let's start with number 1. First, we want to identify the main chain. So that's going to be this kind of line here. And there's going to be 1, 2, 3, 4, 5 carbons here. So that will make the base, or like the main thing, pent. And you can add a substituent. We got one here. And it's a methyl substituent on carbon 3. So it's going to be 3-methyl pent. And then there's also a double bond right here on bond number 1. So that's going to be pent 1-ene. So our final answer for this one, for question 1, is 3-methyl pent 1-ene. Now, number 2, it looks a little complicated, but there's nothing to really worry about here. Let's just identify the main chain. 1, and it seems like the whole thing is really the main chain. So let's just count the atoms. And there are 10, which means the main chain is dec. That's the thing you use. And there was also a triple bond right here. I might have covered it a bit, but there is a triple bond there. And that is on bond number 1, 2, 3. So it's going to be 3-ine. And notice that there's no substituents, so there's going to be nothing over here. And our answer is just dec 3-ine. Okay, number 3 looks a little different because it's in this cyclic or ring form. And when you see stuff like this, you should basically start out with cyclo. Yeah, cyclo is going to be a part of the main chain. So let's count the atoms. 1, 2, 3, 4, 5, 6, 7. So that's going to be cyclohept. And this time there are 2 double bonds, one here and one here, on bonds 1, 2, and 3. So in this case, it's called a diene. All right, so 1, 3 diene. And also, when there's a di here, or tri, or anything like that, you re-add a vowel in here, so that it just sounds nice. So the answer is going to be cyclohepta-1,3-diene. Okay, so number 4 is a little different. Let's just start off with the main chain. That will look like this. and there are 6 carbons in the main chain. So that's going to be hex. There are 2 double bonds, but notice how this one of them is not on the main chain. So this one is actually a substituent. All right. So we can go ahead and put this first one in the name. This is just going to be 1-ene. And this substituent is actually going to come in front of the name rather than being here like the diene. So this is called metheno. So like instead of methyl, it's metheno because of the alkene group. And since it's on carbon number 4, it's going to be 4-methynyl hex 1-ene. Now for some drawing practice. We first just look at the main chain. Draw the main chain first, which is pent in this case. So you can draw a chain with 5 carbons, so 1, 2, 3, 4, 5. On number 2, which will be this one, there's a substituent called cyclopropyl. And that is going to look like this. Because we have a cyclopropane right here. And it's a substituent, meaning that it's not a part of the main chain. We also have 3-ene. So we have an alkene, a double bond on bond number 3. So 1, 2, 3. So this is what it looks like. Now, this next one looks a little lengthy, but it should be fine if you just stick to the basics. Stick to like the procedure and whatever. So first, we just draw the main chain, which is hept, which means 7 carbons. So 1, 2, 3, 4, 5, 6, 7. And now let's start drawing the substituents. There's actually multiple. 1-ethyl right here on carbon number 3, which is this one. Let me just label these first. And then there's 2 methyl groups, one on 4 and one on 5. So that's going to look like this. And then there's 1 double bond and 1 triple bond. One on bond number 5 and a triple bond on bond number 1. So like so. And like this. Alright. That's it. You should try practicing. You should really try practicing nomenclature. It's really important in organic chemistry, especially if you're doing further courses. And yeah, my next video will probably be on ketones and aldehydes. Yeah.